In every infrastructure project, spatial data plays a crucial role. From planning and progress monitoring to operations and maintenance, having complete visibility can impact timely delivery and project management. AGEL's 13-gigawatt Kavda solar plant, spanning 720 square kilometers in Gujarat, is a mega project that relies on large-scale accurate data. Let's look at how machine learning algorithms automatically identify and digitize features from processed drone data on the Aereo Cloud platform. Once a high-resolution 2D map of the site is created, several analytics are enabled on the processed dataset, which is conventionally not possible on satellite data. Using proprietary machine learning algorithms, Aereo Cloud was autonomously able to detect features such as boring, piling, inverter piling, IDT station, cable trench, cables, purloins, torque tubes, and HT and LT structures. Upon identification, these features were digitized, counted, and visualized on a customizable dashboard. This allowed for seamless report generation and instant sharing with all stakeholders. With near real-time updates, project managers can accurately track the progress of various construction activities. High-frequency data collection ensured multiple site iterations and a reduction in turnaround time from 15 days to just 7 days. Through tools such as swipe map analysis, the site plan was overlaid on the actual survey data to compare the difference in project completion. In a single iteration, over 10 lakh critical features were identified and visualized on an interactive dashboard. Reports for each step of construction were generated and shared with all stakeholders. This data was pivotal in S-curve generation and helped reduce the site monitoring and reporting time by approximately 50%. If scaled up over a larger area, the benefits and value addition from this technology can be compounded, resulting in week-on-week reporting. In addition to automated feature identification, insights such as drainage analysis, contour map generation, elevation models, and more can be conducted. This would enable turnaround times as fast as 7 days from data collection to final reporting. Faster turnaround times lead to better project management, inventory tracking, reduction in delays, reduction in cost overruns, and best-in-class efficiency.